Hello guys, and this is the part 5 you can say. Uh, okay, let's stop this. Okay, it's the part 5 of the video you can say because uh, it's not the part of the homework. The homework part ends over here. But while studying the helix, I found something interesting. So I just wanted to share with you guys what I found. So over here, we calculated for uh, when you take different thetas, many thetas, you get this round surface. Okay. So when you change the value of the thetas, for example, 32, we can just say like 5 or something, we'll see the result drastically changes. You see, you're going to get an rectangular channel. Okay, a rectangular cross section, so rectangular pipe along the helix. So just to make it more aesthetic, let's make take more values of theta, means more values of t. Okay. Now, guys, you see it looks like an rectangular pipe, rectangular pipe, rectangular cross section. It follows the helix path. Okay, and the other things will remain same. If you see the area, how much you're getting. 362, 362.9. Okay. Uh, Everything is same, almost same. The area slightly changes, so you don't have to change much things. And you can also play with the the minor and major radii. So let's make it 1 and 1. We'll see you'll get perfect square channel. Square channel which will follow the helix path. So it looks good. And one more interesting thing which I found over here, if you see, if you put 5, the theta value 5, will get this rectangular channel. Sorry. Okay, so if you put the value, the theta's value 5, you will get this rectangle, means the square channel. There are 4 points are there. So I believe what happens over here, when you take, you are taking theta as 0. So it started with this point. So this is the theta 1. Okay, the first theta, theta equal to 0, theta equal to 1, this is theta 1, theta 2, theta 3, theta 4. Okay, and it starts with 0, it doesn't start with 1. Okay, so for 5 values of theta, there are 5 values, it starts with 0. Okay, doesn't start with 1 as per the Python indication, are also given starting with 0. So it just misses the first value. When it starts with 1, theta 1, then theta 2, then theta 1, theta 2, theta 3, and theta 4. So if you give the value of n theta 5, you will get 4 values of theta, because theta 0 doesn't make sense, doesn't make any sense, because if you see the angle is 0 degree, means it starts with the same point only. For example, just take like this, theta equal to, and theta is equal to 3. Okay. So first one is 0, starts with 0, then something like pi by 2, then maybe 3 pi by 2, something like that. Okay. 0 means what? There is no angle between that. So this is nothing. Then pi by 2, then 3 pi by 2, or something like this. Okay. You get something like this. So let's change and play with this thing. Let's change theta to 4. We'll see a triangular cross section which will follow along the helix. As you can see, it's the triangular cross section. Let's uh, change the color to green. So let's change the color to something like blue. Okay, it's taking some time because yeah, it looks nice now. Or you can make it as black as well. Let's not take this template as dark, and you can do it. Okay, let's see now. The area will be same only, so we don't have to care about that. You see, it's the triangular channel. Triangular channel which we're going to follow along the path of the helix. So let's take more points, something like 2000. Let's see what happens, and let's make this value as maybe something like 3 is the minimum. If you take 2, we're going to get different value. Let's take 3 and see what we're going to get. Hmm. I hope it will be something like a plate or something. I believe. Yeah, as I told, it's kind of a strip. It looks like a it's not a movie strip. Movie strip is different, but it looks like a DNA kind of uncalled DNA or something like that. Okay, it won't be proper DNA, but kind of a DNA or kind of a ribbon or something. Okay, so it looks cool. Let's take some other values. Let's change the value of A and B a bit more. Maybe 10, B equal to 10, A equal to 1. We'll see how the result changes. And theta values I would like to take something like 4. We'll see how the triangle will going to look. Maybe something like this. We'll see. Or we'll see. Okay. Okay. It looks completely weird. Completely weird. I don't know what is it. What is it? But it looks weird. Okay. So I think I took a very huge value of B. Let's take it something around 3 or something. Let's see. Mm, maybe it will look a bit better compared to the before. Let's see how it looks. Okay. Okay, it's a triangle with it's kind of uh, this side of the angle is a bit bigger compared to those sides. Uh, now a let's take theta is equal to 5. We'll see how the square will be. It will be some kind of rhombus or something. It's difficult to see with this color. Let's make this uh, black. Maybe black will look better. Yeah, it look kind of better, but I don't know. Can't see the things properly. Maybe some color like yellow or maybe yellow would look okay. It's taking some time because okay. It's kind of better compared to the previous results. You can see properly. It's kind of a rhombus, and it's really interesting. So many things you can do just by tweaking simple values. And let's take around 5, 6. You can take a 6. It will be a kind of a what do you call a pentagon. Okay. So let's take same values only. it makes it really weird. If you take different values of a and b, maybe this pentagon will look better. So pentagonal, what do you call? I don't know. Like pentagonal cross section of a pie. And as you can see, there are five sides of this pipe now. And if you increase the theta more and more, the sizes will get lesser and lesser, and it will look like a sphere, it will look like a circular cross section. Okay, so let's see. Let's take values of a equal to b and a equal to 1, b equal to 10, and let's take more values of theta now, maybe around 25. Maybe this time the ellipse will be something like this. You know, the minor data will be so smaller, and major data will be very much bigger compared to the minor data. So we'll get something like this. Okay. Maybe I haven't clicked shift enter at this point. That's why I didn't take. Let me do it again. It's taking time. Maybe you are given more values of theta. That's why. Okay, as you can see, oh my god, we have taken much more. We have to reduce the value of b. It's very huge. Let's make it around 5. Mm, See guys, it's taking more time because you have to calculating more things. Like for each value of t, it's calculating 25 thetas, and every theta it's calculating 3 values. Okay, and it's doing for 2000 t's. So you just multiply all these values. So this kind of calculation is doing by Jax. So you can just imagine how fast is the Jax. Okay, so we got something like this, a weird shape. Let's make it black or blue or red. Red would be better. And area will be, you don't have to make any changes. It will going to get calculated automatically. I'll see this value. So how many values they are calculating actually? 2000. See, 2000 multiplied by 25 multiplied by 3. So it's like 1 lakh 150k. Okay, 150k values are getting calculated with only no less than 10 seconds or 20 seconds something. It's a weird looking thing. Let's take the values of p2 or something. Let's see what it gives. Okay, it's taking. I need to check. There is a method to check how long it's taking. Okay, it's showing over here. 8 seconds. I didn't get the result. Okay. 8 to 10 seconds. It looks nice now. Okay, guys. So I found this interesting. So I thought of sharing with you guys. So that's all for this video. We'll meet you guys in the next video. Till then, bye bye.